we're going to look at the capacitor, and we're going to look at the plate capacitor because it easily describes the basic of the capacitor. A plate capacitor is two plates with a given area and a given distance, and here we can see we have the electrical field between the two plates. It is nearby a homogeneous field because we have control of the field, because the field goes from the positive to the negative. And over here we can see a picture of the electrical field, and we can see that all the homogeneous fields are in here, and we only got out here that the field is not very homogeneous. So it is nearby perfect, and we can have control of the electrical field. When we look at the plate capacitor, we have, for example, the charge between the plates, the distance between the plate, the area of the plate, the voltage drop of the plates, and the dielectric. It means depends on the material between the two plates of the dielectric. And we have to learn some words and end up calculating the capacitance of the capacitor. That is the basic value for a capacitor. But we start with flux density. It has the letter D, and it is a relationship between the charge of the capacitor and the area of the plate. And the unit is coulomb per square meter. We also have to talk about field strength, the electrical field strength. It has the symbol E, and it is the flux density divided by the dielectric. And the flux density was the charge divided by the area, so we can say it is also the charge divided by the area multiplied by the dielectric. And the dielectric depends on the material, so we have that the number for the dielectric at vacuum and multiply by a relative number for the dielectric depending on the material. So here we have a formula for the field strength in one situation. We also have that the field strength is the voltage across the plates, the voltage drop, divided by the distance. And here we can more easily see that the unit for electrical field strength is voltage per meter. These two formulas we add together and say that the voltage divided by the distance must then be equal to the charge divided by the area and the dielectric for vacuum times the electric relative dielectric. And we can see that the distance, the area, and the dielectric for vacuum and the relative dielectric, it is constant. When we have made the capacitor, these values will not change. So it will only be the voltage and the charge that they will change. So we can say that the charge divided by the voltage is a constant, and it is this number, and we call it the capacitance for the capacitor. It has capital letter C, and the unit is farad. Finally, we can see that the charge of a capacitor is the current multiplied by time. We also know that from Coulomb's law because the charge is amp seconds or coulomb. So there we saw that the unit for charge is coulomb, but it is the same as amp seconds. And we also have that the value for charge is the voltage multiplied by the capacitance. We can see up here, because here we got the charge, and we just move the voltage over here and we multiply by the capacitance. So these are also the basic formula for the charge of a capacitor. So if we want to charge a capacitor, we can lead a current to the capacitor in a given time, and it will give us a voltage drop across the capacitor depending on the capacitance of the capacitor, and the capacitance depends on the area, the dielectric for vacuum, the relative dielectric, and the distance between the plates.